Hello class, welcome to this lesson, which is the last lesson for the topic number 3. And this lesson is about solution of a system of two linear equations in two variables. Yeah, again, it sounds complicated, but remember that in mathematics, the names are more complex than that that it really is, okay? Usually we get very complex numbers for easy concepts. So let's see. Today we're just gonna explore a little bit the concept, and I'm gonna tell you about this problem. Okay, this problem is a very natural problem in which this type of systems of two linear equations arise. So I'm gonna tell you how it works. So let's suppose the following. Let's suppose that I am involved in the following situation. I go to the market with a friend, and we go to buy some fruit. Okay, we have oranges and grapes and apples and bananas and all these things. Okay, and then we decide to buy apples and bananas. Okay, that's the only type of fruit me and my friend are gonna buy, just apples and bananas. Okay, so we pay the seller, we go away, we go towards our homes, and in the meantime, we forget about the price per kilogram of apples and bananas. Okay, at some point during our journey towards home, we think, okay, do you remember what the price was of apples and bananas? And we just forgot. Okay, so what can we do about it? So we get home, and I tell my friend, you know what, I have a weighing scale, which is like una báscula, okay, in which you can measure the weights of any object. And I tell them, you know what, I know how we can solve this problem, the problem of finding out the price of apples and bananas, the price per kilogram, by using this scale and by remembering how much we spent in total. Okay, because that's the only thing that we remember. I remember that I spent 129 pesos in my buying, and my friend remembers that he spent 116 pesos, okay, which is usually what one remembers when somebody buys something. Okay, so we are home, in my home, and we next we measure the weight of my apples and my bananas, and the same for my friend, and we come to this conclusion. This is my conclusion. My conclusion is that I bought 3 kilograms of apples and 3 kilograms of bananas for 129 pesos. Okay, and my friend, he comes to the conclusion that he bought 2 kilograms of apples and 4 kilograms of bananas for 116 pesos. And that's all we know. That's all we know. By using the scale, we could measure these weights, and we just remember how much we spent when buying fruit. Okay, now the question is this, guys. With all of this information, can we know the price per kilogram of apples and bananas? Yes, we can. And we're going to do it by making use of a system of two linear equations in two variables. And it's very simple. Look, first, remember, I'm going to declare my variables. If I'm looking for the price per kilogram of apples and for the price per kilogram of bananas, why don't we declare these two variables? I'm going to declare A to be the price per kilogram of apples, okay, and B the same but for bananas, the price per kilogram. B will represent the price per kilogram of bananas. So basically my goal in this problem is finding A and finding B. So these are the two variables I want to find. Okay, perfect. So how do we do that? Okay, I'm gonna use this knowledge. Okay, I'm gonna use the knowledge of how much apples, or the quantity of apples that I bought and the price I paid, and also the quantity of bananas that I bought. Okay, and the same for my friend. And I'm gonna create or build an equation for each of these two people, me and my friend. So look, if I if I bought 3 kilograms of apples, which I'm gonna write down here, 3 kilograms, and I'm gonna multiply it by A, okay, 3A. When I write this, what does this mean? Well, if A is the price per kilogram of apples, and I bought 3 kilograms of apples, then what this means is the amount of money I paid per because of apples, right? Due to apples. And plus the same for bananas, 3 kilograms of bananas times the price per kilogram. This will represent the amount of money I paid due to bananas. And when I add these two terms or these two expressions, what does that mean? That's the total amount of money that I spent, which, like I told you, is 129. So I write this. You see? So this is the equation that I can build with my information, so to speak. Okay, so you can see that this equation has two variables, a and b. And when you have a linear equation of this type, we call it a linear equation in two variables. And that's what this part of the name comes from, in two variables. Because I have an equation, a linear equation in two variables. You see? Now, can I solve this problem? Can I go ahead and solve the problem just with this equation? Clearly not, because you have two variables, okay? And you cannot know, you have 3a plus 3b equals 129. You cannot know the value of a nor the value of b because you have two variables, you see? And you cannot isolate one and find it. So what do we do? Well, we construct a similar equation for my friend. Okay, if I do exactly the same process, the exact same reasoning, I will be able to find or to create this equation. Yeah, right? It's exactly the same, but with the information of my friend. Okay, perfect. Now remember, let's try to label always the equations. I'm gonna call this equation 1, and I'm going to call this equation 2. You see? Okay, and basically what I want to find one more time is A, the value of A, and the value of B, which is the price per kilogram of apples and bananas. So what we do is this, guys. We can do a very clever thing. And first of all, we call this, when you have two equations in a certain problem, two simultaneous equations, like so, that involve your same variables. You see, the two variables that you are looking for are simultaneously in my equation, the equation 1, and my friend's equation, the equation 2. You see, the same variables. So you can see this as a couple of simultaneous linear equations in two variables. And that's why also we have this word 2, because you have two equations which are linear, and they have both two variables. So now you see why we call them in this way. And when you take them as a whole, that's why we call them a system of two linear equations. So you see, now you understand why it's called this way. Okay, now how do we solve this system? How do I find the value of A and the value of B? By making use of these two equations. Well, that's also simple. It's not complex. I'm going to erase my context. We don't need this anymore. I hope you have appreciated my my poorly drawn bananas. Okay, let's continue over here. So now the goal, now that I have laid down my equations, my goal is to find A and to find B. Okay, here. Okay, so I'm gonna write the equation so one more time here. We have 3A plus 3B equals 129. This is equation 1. And we have 2A plus 4B equals 116, and this is equation 2. Perfect. Now, how do we do it? How do we solve this system of equations? One method of solution is called the substitution method. Okay, this is one of the methods. The substitution method of solution. And that method involves the following. You're gonna do this first. I'm gonna write the steps. Okay, step number one, you're gonna take one equation. Take one equation, either one or two. It doesn't matter which one. It does not matter. Take one equation and isolate one variable. One variable. What variable? It doesn't matter. How do you say that? Whichever, yeah, right? Whichever variable, it doesn't matter. So whichever equation and whichever variable. So I'm gonna decide to go for the first equation, and I'm gonna decide to go for isolating my variable a. So I write down my equation, and then I'm gonna isolate a. Very simple stuff. We can do this already. 129 minus 3b, I forgot that. And then a will be equal to 129 minus 3b over 3. So this is my isolation. Perfect. And we are done with the first step. If you want, frame it, because we're gonna use it in a moment. Okay, second step. Take the isolation, or the isolated variable, that sounds better. Take the isolated variable from step 1 and I'm gonna say plug it, and plug it into the other equation. What other equation am I talking? If you notice, in this first step, I only made use of this equation, of one equation. In this case, equation 1. So now that I have isolated my variable a from the equation 1, I'm gonna put this and I'm gonna plug it into the other equation. What is the other equation? Well, in my case, that would be equation 2, right? The equation that I have not used so far. So what does that mean? Plug it. It means this. If you observe, we have 2a plus 4b equals 116. And let me write that down as it is. You see? And in here, right here, in this a, I'm going to plug this value that I'm circling right now, because that's what a means. I'm sorry, that's what a is. A is equal to all of this in terms of b. So I'm going to put it right there. I'm going to write 2 times a, which is all of this. So I'm going to open up parentheses in this way, over 3. So all of this is a. You see, 2a, 2a. And then we continue with the equation normally. There you have it. Okay, and now, what can you observe, guys? You can observe now that this equation that I have created only has one variable. What variable? B. You see, there is no other variable. You only have the variable b. By doing this trickery, and so you can solve it, because we know by now, we know how to solve equations, linear equations in one variable. That's what we have been working on a lot, and you can solve this equation now. Okay, I'm gonna solve it. I'm gonna multiply this 2 times this numerator. That's how it works. Don't make the mistake of multiplying also times the denominator. That would be wrong. When you have something like this, this number only multiplies the numerator. So that's gonna be 258. This times this is 258. This times this is minus 6b. And then divided over 3 plus 4b equals 116. And then I'm gonna show you the trick. How can I add this fraction with plus this number? Well, make this number have the same denominator as the fraction. How do you do that? Multiply this and divide at the same time by 3. In this way, look. Multiply this by 3 and divide by 3. When I multiply it, I get 12b, and when I divide it, I get 12b over 3. You see, that's what I did. This is completely equivalent to this. And why did I do so? So that I can get two fractions with equal denominators, and I can add them very quickly. Okay, we have this. I'm gonna erase this part because I need to. Then let's continue with the process. Okay, so two fractions with equal denominators, so I can just do this. Okay, like so. And then finally, all of this can be reduced to 258 plus 6b, am I right? Over 3 equals 116. Let's multiply by 3 both sides of the equation, and we get this equals, let me use the calculator, 116 times 3. We have 348, and then 6b equals, let's subtract this number from both sides. That's going to be 90. And finally, I'm going to conclude in here. We divide over 6 in both sides of this equation, and we get 90 over 6, which is ultimately 15. And we are done with one of the unknowns. We have found the price per kilogram. Remember, what was B? B was the price per kilogram of bananas, and we have found it. It was 15 pesos. We are done with this, okay? Yeah, after all this long process, 15 pesos. Okay, and once you have one of these two variables found, once you have found one of these two variables, finding the other is very simple. Just take this value and put it in any equation. Any equation, for example, you can put it right here, okay? You can put this value 15, put it right there, so that you have 3 times 15, you see? And then you can now solve this equation because it will be an equation with just one variable. You can also put it here if you want. It doesn't matter, okay? What else? You can put it right here, you see? You can put it right there, B, put 15, and that will automatically give you the value of A. Let me put it right here, okay? We're gonna get 129 minus 3 times 15. How much is 3 times 15? That's 45. So I'm entering in my calculator that, and then I'm going to divide over 3, and I get 28. When I put B 15 in here, I get that A is equal to 28. And that is my other solution. And we are done, guys, okay? And then remember, just conclude properly somewhere, conclusion. The price per kilogram of apples is 28 pesos with the symbol for currency, and the price per kilogram of bananas is 15 pesos. And that's it. This is my conclusion. This is what I'm gonna tell my reader, and I'm done. Okay, so that's how it works, guys. Now, you may think that this takes a lot of time. It doesn't, okay? The only reason it takes me a lot of time to do it when I explain it to you is that I take a lot of care. I explain myself with a lot of care. When you do it on your own and you do it quickly and you don't have to explain nothing to nobody except you, this takes about 5 minutes or less, okay? It's rather quick. Okay, guys. So this is how you solve these types of problems that involve the solution of two linear, I repeat, two linear equations with two variables. Okay, they present often in application problems like this one. And this is what you do by the substitution method. This first step and then this second step. And that's it, okay? This is just the introduction. We're gonna keep on working with this on Monday, but at least you know how it works at this point. Okay, so now maybe you wanna solve a very, I'm gonna give you a similar problem. Let me raise this. Okay, so now one more time. Well, I'm gonna talk about you. So you're gonna solve this problem. Ah, so you and a friend. Okay, so you buy 3 kilograms of oranges and also 4 kilograms of what? And also bananas. Okay, for a total of 110 pesos. And your friend buys 2 kilograms of oranges and let's say mm, 3 kilograms. Now let's say 5 kilograms of bananas, and she spends 135 pesos. Okay, so this is a new problem, completely similar to the one you have seen before, and solve it. Okay, for this case, for this other market that you're gonna go with your friend and you buy these many things for this amount of price, find me the price of oranges per kilogram, and the same for bananas, the price per kilogram of bananas. Okay, so since I just invented this problem like out of the blue, maybe the prices will not be very reasonable. Okay, so it doesn't matter. Okay, just solve it and we can discuss it on Monday. So that's it, guys. Have a great weekend and see you on Monday. Bye bye.